Hello everybody, today we will be going over an exponents problem at the IB Math Studies level. So we have a population of 200 rabbits which was introduced to an island. They also tell us that 1 week later the number of rabbits was 210. The number of rabbits n can be modeled by the function blah blah blah, where t is time in weeks since the rabbits were introduced to the island. And so for part A we need to find the value of b. Now, of course this can be an overwhelming problem, so it's very important to understand what we have in the problem so far. The first thing that we have is, of course, our trusty rusty function, which is right here. And the other thing that we know is that 1 week later of the rabbits being introduced to the island, the number of rabbits was 210. And so what this is essentially telling us is that at t equals 1, we had an n of 210. Another way to express this same information is that on your point 1, there exists the point 1, comma 210. The other thing that we know is that a population of 200 rabbits was introduced to the island, so that means that on T0 we had 200 rabbits, okay? And in a certain way, that means that we have the set of points 0, comma 200, okay? This second one is a little bit trickier to get. You can also sort of like test it out in a way. You can test out both and see if the math works. So for example, testing out the second one, we have 200 on the left, and on the right side we still have the 200 times b to the power of 0, and anything to the power of 0 is just 1, so we end up with 200 being equal to 200. Now of course this doesn't help us much for finding the value of b, but it's important to understand that setting it up like this could be important for another problem. But for this problem, we're going to use our first version, which was t equals 1 and n equals 210. So I'm going to go ahead and put the 210 here on the left, and we're going to have the t equals 1 up here, right? And so now getting the value of b is going to be much easier. Of course, we want to get b alone, so we're going to divide both sides by 200, and we're going to end up with b being equal to 210 divided by 200, and this is just going to be 21 over 20. And if we get really specific about it, we can go ahead and open up our calculator and plug in 21 or 210, just might as well do the whole thing, divided by 200, right? Gives us 21 over 20. And in decimal form, if this calculator would be friendly with me, is 1.05. So our b is 1.05. So that is for part A. The most important thing I think for part A is understanding that if they give you a piece of information, you know you're gonna have to use it somehow. Okay. Anyway, for part B, we can calculate the number of rabbits on the island after 10 weeks. And so 10 weeks we know is t equals 10, and we don't know what n will give us. Okay, but we can also apply it because we already find the value of b, so we now have our complete function. Our complete function before plugging in t equals 10 is going to look like this. We have 200. We now know the value of b, which is 1.05, and all of this to the power of t, right? But we are plugging in t equals 10, so it will look like this. And I'm just going to go ahead and put this into our calculator and see what we end up with. And of course, we end up with 325.7789. Now, it's important for these problems to understand the context of them, right? You can't have like a rabbit and a half, unless you get really technical about it and say like a rabbit isn't a rabbit until it's born or something like that. Dude, I don't know. I don't want to get political. I suggest that you simply kind of like round it and say we have 325 rabbits, okay? And I say this because sometimes in the mark scheme, this is actually like what they want. They don't want you to put a rabbit in half. They want you to round it um, to its closest number, but you can't have 326. You can't round up here given the context of the problem. That's what I'm trying to say. Anyway, that is for part B. Finally, for part C, they give us that an ecologist estimates that the island has enough food to support a maximum population of 1,000 rabbits, and to calculate the number of weeks it takes for the rabbit population to reach its maximum. Now notice what we did for part B, we were plugging in T and finding an N, and now what we're gonna do is plug in an N, which is gonna be 1,000, and find our T. Okay, so this is not what we're usually used to doing, because the way it's set up looks a little bit weird. It's gonna be set up like this. We will have 1,000 on the left side, and we actually need to get T alone when T is on an exponent. So I know that this can be very uncomfortable, but I have a whole video explaining how to solve problems with variables on their exponent. I suggest that the easiest way to do this is just go on y equals, put one side of it on y1 and the other side of it on y2. I did this on the actual IB exam and I got full credit, so trust me on this. And then, of course, after you figure out your zoom and your window, just go ahead and calc intersect. And so doing calc intersect here, we go ahead and put our first curve, put our second curve, bada boom, bada boom. We end up in the intersection of x being 32.98, which is essentially 33 weeks. And so it is safe to say that for part C, it is just about 33 weeks. Okay, so that is for part C, and that is the whole problem. Remember that here it's important that you dictate this is going to be your y1, like literally write it on your test, and this is going to be y2, and I did calc intersect. Okay, and with that you should be good to go. So that is how you solve this problem, and I hope it helped.